So dear children, in the problem solving series, next we are going to have a close examination on problem from the chapter electricity, that is solved problem solved problem 4, which is on page number 47. So dear children, let us read out the question first. Solved problem 4. The resistance of a wire of length 10 meter is 2 ohm. If the area of cross section of the wire is 2 into 10 power minus 7 meter square, determine its resistivity, conductance and conductivity. So my dear children, what are the terms mentioned here? Area of cross section, resistivity, conductance, conductivity and resistance. So before doing the sum, let us explore the terms together. What do really these terms mean? Let's have a close look on these terms, okay? So dear children, let me try to make you understand what electricity is and the related terminology by using an analogical treatment. What is electricity? Electricity is the flow of electrons, right? So you can easily resonate the idea of electricity by comparing the flow of water. Now this is a pipeline. Now this is in horizontal position, right? This is in horizontal position. Now imagine water is filled here. Now water can flow from this end or from this end with certain speed. If I lean this pipe to certain extent in one direction, what happens? Now the water flows in this direction. So water flow from this end only, right? What is the real cause of the flow of water now? This is because of the height difference. When I place this pipeline in this horizontal position, water flows from these two ends with a certain low speed, or the rate is low. But when I lean this pipe to one direction in certain angle, what happens? Now the water flows through this end only. This is because of the height difference. See, this end and this end, there is a height difference. Because of the height difference, there is a pressure difference. So that pressure difference is the driving force for the flow of electron. My dear children, if you have a conductor, what is conductor? Something or anything which conducts electricity is the conductor. That means consider, say a copper wire or aluminum wire through which electrons can easily flow through. Now that is called conductor. See, if you make a potential difference, if the potential of these two ends are same, no flow of electrons, right? If you make any difference between the two ends, I mean if there is a potential difference across these two ends, if the potential is high at this point, potential is low at this point, there must be potential difference. Now the electrons flows. Now the electrons flow. Okay, that is called electricity. Now I hope you understand the term electricity is, right? My dear children, so you know what is potential difference now. Okay, now what is a resistance? Okay, see here, this is a pipeline, dear children. The inner lining of this pipeline, if it is uneven, hard, with the grooves, cracks, or any deposits or any obstacles inside, then maybe it may be a rust or anything. If the inner surface is not that shiny and smooth, water cannot flow through this pipe that easily. That hindrance, that obstacles, that impediments, that obstacles, it arrests the speed of water. That opposing force which prevents the flow of water, that is called resistance. In conductor also, when electrons flow, when electricity is, when electricity flow, if any opposing force or anything which stops or slow down the speed of electron, or anything which opposes the flow of electron, that is called resistance. Okay, now I hope you understand what is resistance, what is electricity, what is potential difference. See, when there is the difference in potential between two ends, Now this is called potential difference. It is the driving force for the electrons to flow. And anything which opposes the flow of electron, which hinders the flow of electron, which arrests the flow of electron, which slows down the flow of electron, which is an opposing force for the flow of electron, that is called resistance. So my dear children, now I want to make you know one more thing about the resistance in two scenarios. Okay, I have a long pipe and I have a short pipe, right? Consider water flows through these two pipes. Okay, for this pipe, water has to travel from this end to this end. That means it has to make a long travel. But in this case, water has to travel from this end to this end, but this is short compared to this one. Okay, now imagine or consider in these two pipes, the inner lining of these two pipes are having resistance or some deposits, something which arrests the flow of water. Now as the distance, as the length of this pipe is more, it has to make a long travel. The resistance is high because water has to make its flow from this end to this. Water crawls, somehow it reaches at this point. That means it has a high resistance here. But in this case, even though some resistance or some uneven surface or rust or obstacles or deposits or anything, if it is, even though it is there, water will have what, some enough space to make its flow high compared to this one. That means since the length is short, resistance is short. So the resistance is directly proportional to length. As the length of the conductor increases, resistance also increases, right? Now another scenario, dear children, when a pipe is cut into pieces, you get a cross section. This area, now this area, not this one, this is a circumference, this area, now this area is called area of cross section. For this, the area of cross section is small, and for this, area of cross section is high, right? Now consider, imagine out of these two, which one has a great flow, this one or this one? Water can make its flow fast and smooth in this, because as I have said already, even though some uneven surface, some obstacles or anything may be there, water will, even then it has what, certain space to make the flow fast and smooth. That means area of cross section is high, the flow is easy. That means resistance is less. As the area of cross section increases, resistance decreases. But in this case, already it is narrow, and if the inner lining is contaminated or if it is having some impediments or obstacles, if the inner lining of this is hard with grooves, cracks or some deposits, now the already narrowed inner lining of this pipe even get narrowed, right? So cannot make the water flow that easily. That means as the area cross section is small, resistance is high. Now you connect these 2 points. Resistance is directly proportional to length and inversely proportional to area cross section. Have I made my point clear to you, my dear children? Can you understand? If you cannot, you please rewind this video again and again till you understand the concept very much clear. Okay, will you do that? So let's jump into problem number 4. What is given? The resistance of a wire of length 10 meter is 2 ohm. So the length of the conductor, shall I draw a conductor here? So just imagine this is a conductor, okay, conductor. Now given the length of the conductor, length means L, its symbol is L, equal to 10 meter. Resistance means the struggle of the conductor to make the electron flow. That is resistance is its symbol is R, that is 2 ohm. The unit of resistance is ohm. You can make a symbol or you simply write to OHM. You can use in either way. Either write in letter ohm or you can use this symbol ohm, right? and its area of cross section. Dear children, this is the area of cross section. This is area of cross section. So simply I write area, and its symbol is A. That is 2 into 10 power minus 7 meter square. Yeah. Now we have to calculate resistivity. Okay, here I write. So in this problem they are asking us to find the resistivity. Resistivity, the symbol is resistivity, the symbol is rho. Okay, rho. Then what? Conductivity, the symbol is sigma. And conductance, the symbol is G. So for all the calculations, for all these calculations, we need to have resistance. Okay, resistance, that is already given, and its symbol is R. Okay, now first we must know the formula for finding the value of this. We must know the formula for all these quantities. So for that I again wish you to have a revisit on the explanation on resistance that I have given just now. Okay, we know, see, this is a conductor and this is another conductor now. Okay, this is another conductor. We know resistance is directly proportional to length. As the length increases, resistance increases. As the length decreases, resistance decreases. So R is directly proportional to L, and R is inversely proportional to area of cross section. Here the area of cross section is large, here it is less, and it is inversely proportional. Now connect these two. Dear children. Shall I put a line here? Yeah, for the easy understanding. Now R is proportional to L by A. Connecting these two equations, these two relations, now we get another relation, R proportional to L by A. See, this proportional can be made into an equation. For that we can use a constant here. R is equal to rho into L by A. This rho is called resistivity. The another term for resistivity is specific resistance. Okay, specific resistance. Resistivity is otherwise known as specific resistance. Why this is called specific resistance? That means when you put the value of L and A as 1, if the length is 1 meter and the area is 1 meter square, now these two values become 1 and 1. So R becomes rho, because L, value of L is 1 and the area is 1. 1 by 1 is 1. Now R becomes rho. Now what is this rho? Rho is nothing but a resistance. When L is 1 and the area is 1, that means in the specific condition, when the length of the conductor is 1 and the area of cross section is 1 meter square, in this specific condition, this rho becomes a resistance. So this is nothing but the resistance. So this is called specific resistance. Now what is our resistivity? Now what is conductivity? Conductivity means it is the reciprocal of resistivity is conductivity. So resistance means it is a struggle that makes the electron flow hard, that is called resistivity. And the conductivity means what? It is the ease of the conductor that makes the conductor ease for the flow of electron. Now this conductivity is called reciprocal of resistivity, or conductivity is equal to 1 by rho. And what is conductance? Conductance is the reciprocal of resistance. Again I say, resistance is a struggle, or it is a difficulty of the conductor which makes the electron flow not easy, and conductance, it is the ease of the conductor that makes the electron flow easily. So these are the formula you must always remember while doing the problems related with resistance, conductance, resistivity and conductivity. Okay, now we are into the problem. Now we are going to solve out the problem 4. Dear children, as I said, now resistance R equal to rho into L by A, right? So what is rho now? Rho is equal to, now we can make some arrangements here. So A comes here and L comes here, right? R into A by L. So just to make some internal arrangement, you get a rho is equal to R into A by L, okay? And sigma, that means conductivity is 1 by rho. Then what? Conductance G equal to 1 by R. So these are the formula you must remember, okay? Now we are going to calculate the values of all this. So rho or specific conductance or resistivity is equal to, rho is equal to R. What is the value of R here? It is 2 ohms. So 2 into, what is the length here? What is the area here? It is 2 into 10 power minus 7 by length. What is length? Length is 10 meter, right? So the value becomes 4 into 2 into 2 means it is 4 into 10 power minus 7. Now 10 is in the denominator. It comes up and it becomes 10 power minus 1. The value is 4 into 10 power minus 8 ohm meter. Why ohm meter? Here the resistance value is ohm, resistance unit of resistance is ohm, and area means it is meter square, and length is meter. See here, rho meter square divided by meter. This meter and this meter get cancelled. You get ohm meter, so the value is ohm meter. Resistivity is 4 into 10 power minus 8 ohm meter. Now what is conductivity? Sigma equal to 1 by rho. That means 1 by 4 into 10 power minus 8. Now the unit also get reversed, reciprocal. So ohm raised to minus 1. Ohm means ohm raised to minus 1 here because it is reciprocal, and meter raised to minus 1, right? So the value 1 by 4. 1 by 4 is 0.25. And this 10 power minus 8 is in the denominator now. It becomes the numerator. So it becomes what? 10 power 8. Ohm raised to minus 1, it can be written as mho. When you write ohm in a reverse way, you get mho. You can write ohm raised to minus 1 or mho meter raised to minus 1, right? So this is the value for conductivity. Now conductance, G. G is reciprocal of resistance. Resistance is given here. So 1 by, what is the resistance value? Resistance is 2, right? 2. That is equal to 0.5, 1 by ohm. That means ohm raised to minus 1, or you can write mho. 0.5 mho. Hope you understand, my dear children. See, if you don't understand this, kindly make a revisit on the entire video. Definitely you will get a clear picture on resistance, resistivity and conductivity. Okay. Thank you so much for watching all this. Please have a close look on these quantities: resistivity, conductivity and conductance. And dear all, if you find useful on this video, then please like, share and subscribe. Share to all your friends, relatives and students, so this will be helpful for them. And also please press the bell button so as to get the notification as soon as I post the video on YouTube. Thank you so much for watching.